if you want to go forward with this, is indeterminate form. Everybody say indeterminate form.
Indeterminate form.
Cool. So it's called indeterminate form. The English prefix in means not determinant, so not determinable. I can't determine what this is actually going to look like with 0 over 0. Okay? So we're going to do some work behind this 0 over 0 piece, but Adrian told us that 0 over 0 tells us it's going to be a what? Did you say it? Somebody said it. Oh, somebody said it.
Oh,
We wrote it in our notes from last time, or it's on the little side. Who is that? Yeah. So, yeah. Oh, I did say that. Who said that? So 0, when we plug in and we get 0 over 0, that tells me that I'm going to have a removable discontinuity. Everybody say removable discontinuity.
Removable discontinuity.
Cool. So this is the calculus word, so we don't actually care too much about that. Right now in pre-cal, we care about it being a removable discontinuity. So since when I plugged in -1, it gave me that my function was undefined. This one is where my vertical asymptote is going to show up. My removable discontinuity is going to show up as a hole in the graph at x equals to 1.
Yeah, open.
Open circle, yes, absolutely. We saw that on the graph that last time that we looked at the graph. Will you explain to your neighbor the difference between how do I know I have a vertical asymptote versus my removable discontinuity? Explain that to your neighbor. How did I get to there? Vertical what?
You get your removable discontinuity by plugging in f of -1 and f of 1. And since f of -1 doesn't give you an indeterminate form, it's only undefined. But since when you plug in 1, it gives you indeterminate. So then you're able to use removable discontinuity.
Okay.
I get it now.
Are we good?
Yes.
Okay. So, if you're looking at your graph, then I went ahead and put my vertical asymptote on x equals -1. And then I'm going to do something at x equals to 1. I'm going to figure out what that is in just a couple of minutes. In the meantime, you know how to find horizontal asymptotes. Will you figure out with your neighbor how to find the horizontal asymptote? What is the horizontal asymptote of this function?
Is that when you set it to like the 1 billion? Yeah. Oh man, that just looks like a regular dash. Wait. Wait, I forgot how to find the. No, like I seriously forgot. I don't know how to. That's just not it. I just know that if it's greater than what did Nico say? He said when when the top is greater and then the bottom is like less than, and that's like when it becomes 0. It's like this. So is it 0? It's exactly this. So it's 0. Yeah, because the horizontal. Yeah. Okay. Yes. So it's okay. Y equals 0. We have to write it. We're done. Wait, but I have a question. When you do the 3 over 1 billion, you know how you have to do the negative? Do we use the 0 over 0? Does that matter?
Right.
Because it's indeterminate. So would you use it?
When the degree of the denominator is bigger than the degree of the numerator, then the asymptote is y equals to 0. If the degrees are the same, it's the leading coefficient. Yes, ma'am. You got a question?
Yeah, wait, do you need to use the indeterminate form for when you're finding the vertical, mean the horizontal?
So the indeterminate form is when I've already plugged in a value. When I've already plugged in f of 1
We're doing the horizontal asymptote of this equation.
of your original equation.
Oh, okay, so then it would just be y equals 0 for the horizontal?
Correct.
Oh, yeah,
Thank you for
of
saying
x.
y equals. Next stop.
X minus 1, x squared minus 1. Yeah,
Right.
that one. Mm-hmm.
I need your attention back up here in 5, in 4, in 3, 2, 1. Thanks. David, did you get an equation for your horizontal asymptote? What did you get? Yeah, so for my vertical asymptote, my equation was x equals -1. So did you get an equation for your horizontal asymptote? What'd you get? Y equals to 0. Do you guys agree?
Yes.
Great. Okay, so let's double check here. I was looking at horizontal asymptote means the end behavior. So we're looking at as x approaches infinity. Did you pick a number close to infinity? What'd you pick?
1 billion.
1 billion. Cool. If I'm looking only at the numerator, which piece matters the most if I plug in a billion? Just the x piece. If I'm looking at just the denominator, which piece matters the most?
X squared.
X squared. You can either do 1 billion over 1 billion squared, or if you want to simplify this thing, we get 1 over x. If I do 1 divided by 1 billion, I have one pizza that's cut up into 1 billion slices.
You get nothing.
I get nothing. That's how I got y equals to 0. So far, so good.
Yes.
Okay, so now I know that my horizontal asymptote happens at y equals to 1, so I'm going to go ahead and put that on the graph. Did you put that? Oh, 0, my bad. Sorry.
Yikes.
Okay, y equals to 0. That's much better. Did you put it on the graph?
Yes. Right now.
Okay. So, here comes the new stuff. Stop. We're fine. Okay. Oh, we're going to graph, yeah?
Yeah.
Okay, so notice that I basically am stuck into 4 different areas. I have this area up here, I have this area down here, I have this area over here, and I have this area over here. My graph always wants to snuggle up next to my asymptote. So I just need to figure out where my graph is going to snuggle to. Okay, I need to figure out if my graph is going to snuggle here or here. And then what happens if it's here or here? If you're with me, say yes.
Yes.
Okay, so let's do the left-hand side first because I need to worry about this hole in a minute. So go ahead, how am I going to figure out what I should do? Make a chart.
And then
Plug in numbers. Okay, so what happens when x is equal to -1? What happens to my graph?
Undefined.
It's undefined. What happens when x is equal to 1?
Undefined.
It's still undefined. When we plugged in both of those values, it was undefined, this was undefined with my indeterminate form. Okay? So I want to pick out something on this left-hand side. What is a number to the left of -1?
-2.
-2 or -3, I'll take either one of those things.
Sorry.
You're gonna plug them in.
What?
Wait, this.
Mr. Kevin?
If I were just to plug, so I have to plug in from this form of
From the very original equation.
Oh,
Okay, and then -1 is 3. It's equal to -1?
Yes.
Yeah. You were gonna tell me I was wrong too.
Oh, because I did. Oh, yeah.
You were gonna tell me I was wrong
Because I
too.
didn't get the numerator at first.
But the numerator is -3.
Okay. Yeah. Oh, you can.
But would you go opposite though? Y equals 0? I don't know. What? Wait, never mind. Wait, I was looking at something else.
You can. We should just get 1, yeah? All right, when you plugged in -2, Brian, what'd you get when you plugged in -2? -1. Okay, so at -2, my y value is -1. Oh, -1. Are you guys agree?
Yes.
Okay. So then that tells me that this graph shows up in this section. It doesn't need to be perfect. I don't need like exact points. This one exact point is kind of enough for me to go ahead and make my graph approach the asymptotes. Your graph is always going to snuggle up next to your asymptote, so you want it to approach. Just the one is fine with me. As long as my arithmetic is correct and I'm on the correct side. Right?
Yes.
Okay. I'm going to erase some things. Okay. Ready for these? Okay, so now I'm going to start dealing with where this hole is going to happen. We said that we had the indeterminate form so that we know that there's a removable discontinuity, which means it's not going to be a vertical asymptote. We said that there was going to be a hole in the graph, an open circle at x equals to 1. Okay? So I need to figure out, where does that hole happen? I know the x value happens at 1. It's going to be my job to figure out where the y value happens. I can't plug in 1 into the function though, because it just gives me 0 over 0. That doesn't tell me anything. But what I do need to notice is that this thing factors. What does the denominator factor into? X minus 1 and x plus 1. Fine. So what? By the way, this is x equals -1, and this is x equals +1. You with me?
Yeah.
Okay? So if this is x equals +1, that's my x minus 1 factor. What do we notice? So I have the same thing in the numerator and the denominator. I'm going to factor to divide to cancel here, which leaves me with what new fraction? 1 over x plus 1. So this is just the simplified, rewritten form of my OG function. Okay, all I did was I rewrote my form of my OG function. You guys with me?
Yeah.
Okay, so here's what, actually, take 20 seconds with your neighbor, make sure they understand how I got my rewritten function.
All you did was do a factor, and then you did
Does that make sense?
So it's just a more simplified version of it. So now that we're looking for our hole, because we have a hole in 1 on our graph, to simplify our original rational function, we're just going to take x over 1, and then we're going to break up the denominator because it can be simplified into x minus 1 and x plus 1. And since x minus 1 can be divided out with x minus 1 over the top, our new rewritten form will be 1 over x plus 1.
+1, sweet. +1. You're a +1. Okay. Alright, so here's the deal. I have, what do I want to say? So notice, in this particular form, when it's written like this, I still have that x equals -1 in the denominator. If you're with me, say yes.
Yes.
I still have that x equals -1 in the denominator, which means that I'm still going to have my vertical asymptote there. In this rewritten form, I don't have a problem with plugging in x equals to 1. I am okay to plug in x equals to 1 in this form. So if I plug in x equals to 1, what do I get? Oh, I can't write x equals 1. What do I get when x equals to 1? I get 1 over 1 plus 1, which is 1 over 2. So my hole happens at 1 comma 1/2. The way I know where my hole happens is because of my rewritten simplified graph. Okay. By the way, another reason we call it a removable discontinuity is I removed the problem. This was where the problem was, and I removed it. Okay. So now I know that